In this video, we're going to continue our discussion on frequency distributions. This time we're going to look at grouped frequency distributions. When is a group frequency distribution used? It's used when the data must be grouped into different classes. Then those classes are going to be more than 1 unit apart. So we just looked at categorical frequency distributions. Those categories were different qualitative variables. Now we're going to look at with quantitative variables. So here's an example of some data that we've collected. Age of students in a community art class. We see that all of these classes that we have here have intervals between them. 10 to 14, 15 to 19, 20 to 24, and so on. So instead of them having qualities, like in our previous video, we had wheat, we had insects, and so on, different characteristics. Now our classes are numerical values. So 10 to 14 would be called a class, 15 to 19 is a class, 20 to 24, and so on. The numbers that are within those classes, the smaller numbers that make up, are called lower class limits, whereas the larger numbers are called upper class limits. There's a gap between 14 and 15 and 19 to 20. There's gaps between the upper class limit of one particular class to the lower class limit of the next one. So we have to come up with boundaries. In our class boundaries, we have a lower class boundary, we have an upper class boundary, and we can use those values to come up with what we call a class width, where we take the upper class boundary, the larger number, subtract from it the lower class boundary, that would be called the class width, and those class widths should remain consistent throughout the entire table. And then finally, we have our number of subjects in each class. So since we're talking about ages here, what's the age? How many students are between the ages of 10 and 14? In that particular class, there's 10. How many students are between the ages of 15 and 19? There are 18. 22 students in the class of 20 to 24, and we can continue that out through all the data points here. So there's lots of information that's within these distributions. Okay, so what are class boundaries? We haven't really discussed what a class boundary is. The purpose for them is used to separate the classes so that there's no gaps between the frequencies. As I said earlier, in one of our classes, the upper class boundary was 14, but the lower class boundary of the next was 15. There's a gap between the number 14 and 15. So we use these boundaries to keep them connected so they can be continuous. So a good rule of thumb that we will use to find class boundaries, we'll always have one additional decimal value, and that decimal value should end with a 5. So give me some examples. Say we have a class that already has decimal values in it. The class is called 7.8 to 8.8. We need to add an additional decimal value to this, and it should end with 5s. The lower class limit, we will subtract 0.5 from it. The upper class limit, we're going to add 0.05 to it. So this would be the boundaries for this particular class, 7.75 to 8.85. So as I said, always take your lower class limit, subtract from it an extra decimal value ending with a 5. Take your upper class limit, add to it another decimal value of ending with a 5. What if our class does not have decimals? Well, we don't need to do 0.05. We're going to subtract 0.5 from 58 and add 0.5 to 64. So the boundaries are 57.5 to 64.5. All right, now we know how to find the boundaries. We've got an idea what the upper class limits and lower class limits, the boundary limits, and so on. What are all the attributes that are used to describe a frequency, a group frequency distribution? One, should always have between 5 to 20 classes. We don't want to be lower than 5. Our data is going to be thrown into too many different classes. We're not really going to get a true reading on all of the data. 2, it is preferred that our class width to be odd, but it's not an absolute necessity. 3, your classes must be mutually exclusive. You shouldn't have a data point that is in one class that could also fall into a second or a third class. It should only fit into one class. 4, your classes must be continuous. There shouldn't be any gaps. 5, classes must be exhaustive. all of your data has to fall within a class somewhere. You shouldn't have a data point that falls outside of one of your classes. And finally, 6, your class width must all be equal. So reminding you again of all the data, or the data that we start with at the beginning of our video, let's go through all of our checkpoints. 1, do we have at least 5 to 6 classes? Well, if we count up all the classes that we have here, we see that we have 6. That is definitely between 5 and 20. So that checks the box. Preferred class width is odd, but it's not a necessity, but we'll take, with our first class, our upper class boundary, subtract away from it the lower class boundary, that is 5, and it's an odd number. We've got what we preferred, so we're good there. 3, are the classes mutually exclusive? Classes don't overlap. There's not an age that falls within 10 to 14 that would also fall between 15 to 19 and continue out to the rest of our data. So this is definitely mutually exclusive data. 4, are the classes continuous? Well, they are going to be continuous because the upper class boundary for all the classes is also the lower class boundary of the next class. So all of our data would be connected here. So if we were going to make a histogram out of here, all of the bars would be connected. The only caveat to this is that if one of our classes happens to have a frequency of 0, if there's no 0 in there, then one of the bars would not be connected. However, the data is still considered continuous. 5, the classes must be exhaustive. We don't have a whole lot of extra background information to this data, but we do know that there shouldn't be a student that's over the age of 39. If there was a student over the age of 39, then we would have to add in an extra class from 40 to the next age. Okay, and finally, all the class widths have to be consistent. They have to be exactly the same. We checked it in step 2, but if you look at all of the class boundaries subtracted, the upper class boundaries subtracted from the lower class boundaries, that's all an interval of 5, so that does stay consistent. So if it's all of our attributes, we know that this data that has been collected is an example of a grouped categorical or a grouped frequency distribution. So there's all of your attributes that you need to know and how to